Hi everyone, welcome to a new lecture series on machine learning using Matlab and Python. In this lecture series, we will be discussing the basic concepts of machine learning and also illustrate how to implement various machine learning programs in Matlab and Python. In this first lecture, we give a brief introduction to machine learning, which is then followed by a discussion on some of the preliminary concepts from mathematics. Machine learning or ML deals with solving practical problems by constructing or learning models using data. Here by machine, we means a computer, and data can be in any form such as numbers, text, audio, image, etc., which contains useful information about a particular problem of interest. And by model, we means a function or an algorithm which can be applied to the data to extract useful information from it. The term machine learning indicates that here the machine is trying to learn a model from the data. In this context, we can say that machine learning is a branch of the following areas such as computer science, since here the machine is a computer, and data science, since ML uses data to learn the model, and finally mathematics, since the learning task in ML is performed using mathematical tools, especially from areas such as linear algebra, optimization, and statistics. In fact, machine learning is mostly originated from statistics and can be considered as the modern way of doing statistical analysis. In this lecture series, we will be mostly focusing on the mathematical aspects of machine learning. We will also discuss the programming aspects, in which we focus on the implementation of machine learning algorithms in Matlab and Python. Before going into the different aspects of machine learning, we can briefly discuss about data and model. In general, data contains useful information about a particular problem of interest. In the real world or the physical world, the data is mostly in the analog form, whereas in the computer world, the data is digital. Here by analog, we means continuous in time and space, and by digital, we means discrete in time and space. As an example, we can consider a sound signal as shown in figure 1. And here, this signal is obtained from a mic or some audio sensors, which converts the actual sound wave into some electrical signal. And in real world, the signal is in analog form, which means both the time t and the variable x of t are continuous variables. Here we can call this x-axis as the time axis and this y-axis as the space axis. If we consider this sound signal of 10 seconds duration in continuous time, then there are infinite number of time instants between 0 and 10. This is because there are infinite number of real numbers between 0 and 10, and in general between any two real numbers. Therefore, if we try to store this sound signal in continuous time and continuous space, there will be infinite number of x of t values, and each x of t value will be a real number. So we need infinite memory for storing this signal in continuous form or in analog form. Therefore, in computer, we usually store the data in digital form, in which we take a finite number of samples from this interval, with each sample has a finite precision. For example, we can divide this time interval into 1 lakh instance, and the time instance can be stored as the elements of this matrix T, and the corresponding x of t values are stored in this matrix X. So this will be the value of the signal X at t equals 0.001. This basically shows that data can be stored as a list of numbers. Now, if we want to process this sound signal for getting some information, we can just process these numbers using some algorithm. Similarly, we can represent other forms of data such as text, image, video also as a list of numbers. Therefore, from here onwards, whenever we say data, we means a list of numbers like this. Now by model, we mean some operator or function which transforms the data into insights. Here by insights, we mean some useful information which are hidden in the data or which are not so obvious. Now in machine learning, our objective is to design an algorithm which uses the past data about the problem of interest to learn a model. and that model is then used for extracting useful information or insights from the new data or the real-time data. Here, this phase we call as the training phase, in which the past data or the historical data is used for training the model, and a part of the past data is used for validating the model. Then in this phase, which is also called as the testing phase or the implementation phase, the model is used for solving a practical problem of interest. So machine learning is all about learning a model using the available data and use it for solving a particular problem of interest. Based on the application, the problem of interest can be of different nature, such as predicting the future growth of a company, or detecting spam emails based on its content, or classifying an image into different categories, etc. Next, we briefly discuss some preliminary mathematical concepts which are used in the machine learning. We start with the definition of set and function. In general, a set is a collection of objects satisfying a common property. A set can be defined explicitly by listing all its elements, or it can be defined implicitly by using its common property. For example, the set A can be defined explicitly by listing all its elements, which are -1, 0, and 1. Or it can be defined implicitly as a set of variables x, where x is an integer and -1 less than or equal to x less than or equal to 1, which is only satisfied by these three numbers. Here, this set A is a finite set since it contains a finite number of elements, whereas the set n, which is a set of natural numbers, is an infinite set. Now, a function f can be considered as a mapping from a set A to another set B, which maps each element x in A to a unique element f of x in B. In general, a function from set A to set B is denoted like this, which means f is a function from set A to set B. And we call A as the domain of the function and B is the codomain. Now, a composite function is a composition of two functions, and for the functions f1 from A to B and f2 from B to C, the composite function is denoted as f2 of f1, which is a function from A to C. We can also have composite function of more than two functions as well, and many of the models used in machine learning are in the form of composite functions. Figure 3 shows the analogies between various domains. The mathematical world is built of mathematical objects and operators. Sets and functions can be considered as generalizations of mathematical objects and operators. Set is basically a collection of mathematical objects relevant to the problem of interest, and function can be considered as an operator which operates on the input set or domain and gives an output set or range. When it comes to the machine learning world, data is the equivalent of set and model is the equivalent of function. In machine learning world, the model operates on the input data and transforms it into output data or insights. Finally, in the physical world, we have signals and systems as equivalents of sets and functions. Here the input signals, which are corresponding to some physical quantities, will pass through the system and it results in some output signals. Next, we move on to linear algebra. And linear algebra is a branch of mathematics which studies linear equations. The theory of linear algebra is built on vector spaces and operations on it. A vector space V consists of the set of mathematical objects called vectors on which the operations of addition and scalar multiplication can be defined. Also, the addition and scalar multiplication should satisfy a number of properties such as commutativity, associativity, distributivity, existence of additive and multiplicative identity, etc. We can consider vector space as a special set on which the concepts of linear algebra are built on. The examples of vector spaces are the set Rn, which is the n-dimensional real coordinate space containing real vectors of length n. The set R raised to m by n, which is the set of all m by n real matrices. The set C, which contains the set of continuous function in the closed interval a to b, and the set Pn, which is the set of all nth degree polynomials. In the context of vector space, we can call the elements of all these sets as vectors. However, when we normally say vector, we usually refers to the element of the set Rn. A vector or coordinate vector can be considered as an array or list of numbers like this, which we call as a column vector. We can also have the row vector form like this, and this notation means the transpose of the vector x. Also, we consider the vector x is an element of Rn, which means that x has small n number of elements and each element is a real number. Now, a matrix can be defined as a rectangular array or table of numbers arranged in rows and columns like this. Here, the matrix A has m number of rows and n number of columns. The matrix A can be represented as an array of column vectors like this, in which AC1 is the first column of A, and AC2 is the second column, and ACN is the nth column. Similarly, a matrix A can also be represented as an array of row vectors in which AR1 is the first row, AR2 is the second row, and ARM is the mth row. We consider the elements of the matrix A as real numbers. This means that the matrix A is an element of the set R raised to m by n. In general, linear equations can be either static equations as in equation number 3 or dynamic equations as in equation number 4. In static equations, the variables x1 to xn are not changing with time, whereas in dynamic equations, the variables are changing with time. That's why we have derivatives here. If we make this derivative term 0, then this equation also becomes a static equation. Here, by collecting all the variables x1 to xn in a vector x and the coefficients a11 up to amn in a matrix A and the constants b1 up to bm in a vector B, we can compactly represent these static linear equations in the form Ax equal to b, where A is an m by n matrix, x is an n-dimensional column vector, and b is an m-dimensional column vector. Similarly, we can represent these dynamic linear equations in the form of dx by dt equal to ax, where A is an n by n matrix and x is an n-dimensional column vector. Next, we briefly discuss some basic optimization ideas. In general, an optimization problem can be represented as in equation number 5, which consists of a decision vector small letter z and a constraint set z and a cost function j, which is a function of the decision vector z. Here, the cost function is also called as an objective function or loss function, which is a scalar valued function. And for each decision vector z, it gives a scalar value, which we also call as the cost. The decision vector z is considered as a p-dimensional vector, so it contains p elements. And the cost function j will be a function of the decision vector, and it can be either a linear function or a nonlinear function. This is the general form of a linear cost function, and in the case of nonlinear functions, we can have many possibilities. One of the major nonlinear cost functions are the quadratic cost functions, which are of this form. Other than this, we can also use modulus functions, logarithmic functions, etc. to formulate the cost function. And finally, the constraint set Z will be a subset of Rp, which contains the set of feasible choices for the decision vector Z. Now in optimization problem, our objective is to find the decision vector Z, which minimizes the cost function J. In machine learning, our objective is to learn a model from the available data set. And we usually fix some structure to the model with some free variables. Then we use some optimization algorithms to optimize the free variables in the model. So the free variables in the model can be considered as the decision variables of the optimization problem. Next, we briefly discuss some basic concepts from statistics. Statistics is a mathematical branch which deals with collection, analysis, and visualization of data. Two of the main objects in statistics are population and sample. A population is defined as the entire data set about a particular problem of interest, and a sample is basically a subset of the population. As we have already discussed, in real world, the data is in analog form or in continuous form. And we can consider this population consists of this analog data. This means that the data in the population can be of infinite dimensional or it contains infinite numbers. Then the digital data can be considered as a sample from this population, where we take finite number of samples from this population, which results in finite dimensional data. Descriptive statistics is basically focusing on the sample, and we are trying to describe or summarize the data in the sample set using different indices. Whereas in the inferential statistics, we are focusing on the population, and our objective is to make inferences or predictions about a population based on the sample data. In this context, we can see that machine learning is more related to inferential statistics, since in machine learning, the basic idea is to make inferences or predictions based on the sample data. Next, we define mean and variance, and for that, let's consider n observations of the univariate data x as in equation number 6, in which x1, x2 up to xn are n different observations of the variable x. Here, the matrix X contains n observations or samples of the variable X, which are denoted by x1, x2 up to xn. Now, we denote the mean value of X as x bar, which is computed as in equation number 7, which is basically the average of the variable X across the n samples. And we denote the variance by sigma x square, which is basically the average of the squared value of the deviation of each observation from the mean value. Here, the variance basically describes how the observations are spread across the mean value. So if the variance is small, the observations are more closer to the mean value. On the other hand, if the variance is large, then the observations are more spread in nature. Similarly, for n observations of the multivariate data or the vector x as given in equation number 8, we define the mean vector and sample covariance matrix as in equation number 9. Here we have considered the observations or samples as column vectors, which is the normally used notation in mathematics. However, when it comes to data science, people normally use row vectors to represent observations or samples or feature vectors. Next, we discuss the different types of machine learning algorithms. Based on the nature of available data and problem of interest, machine learning algorithms can be grouped into different categories such as supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, available data or past data is in the form of inputs and target outputs, which are also called as labels. Here, the objective of the algorithm is to find a model which maps the inputs to the labels. Then, the model can be used for predicting the labels for a new input or real-time input. Here, while learning the model, the past data or training data acts as a supervisor, which says that for this input, this should be the output. And the machine learning algorithm should find a model which matches with the input output data. Now, in unsupervised learning, the available data or past data contains only inputs or unlabeled feature vectors. The unsupervised learning is used to learn a model that takes a feature vector as the input and transforms it into another vector or a value that contains relevant information to the problem of interest. Finally, reinforcement learning or RL is used for solving decision-making problems. And here the objective is to learn a sequence of decision or policy using the available data. In short, for supervised learning, the data is labeled, and for unsupervised learning, the data is unlabeled, and for reinforcement learning, the data is dynamic, which is mostly obtained from a dynamic process or system. And here we have listed some of the popular algorithms in supervised learning, unsupervised learning, and reinforcement learning. And we can also have another category called as semi-supervised learning, which comes in between supervised and unsupervised learning. In semi-supervised learning, the available data consists of both labeled and unlabeled inputs. The figure summarizes the various types of machine learning algorithms. As we have already discussed, The machine learning algorithms can be divided into supervised learning, unsupervised learning, and reinforcement learning. The algorithms in supervised learning can be further divided into regression and classification. In regression, the label is continuous, and in classification, the labels are discrete and can take only a finite number of values, which we also call as classes. In general, regression problems are used for predicting the output value in a continuous range for a given feature vector, and classification problems are used for predicting a class or category of the feature vector. The main types of unsupervised learning algorithms are dimensionality reduction and clustering, where dimensionality reduction is similar to regression problem and clustering is equivalent to classification problem. Finally, the reinforcement learning algorithms can be divided into model-based approaches and model-free approaches. Whereas in model-based approaches, we use the idea of a model of the system, and in model-free, the model information is not used. Some of the major algorithms in each of these classes are listed here, and we will discuss these algorithms in the upcoming lectures. Next, we give a brief introduction to machine learning using Matlab and Python. Matlab and Python are basically high-level programming languages and can be used for implementing machine learning algorithms. Matlab is the short form of metrics laboratory, and it basically uses vectors and matrices for storing the data and implementing the operations on data. Matlab has different toolboxes such as deep learning, statistics, and machine learning, which can be used for implementing machine learning algorithms. As a first step, we can see how to read data in Matlab, and here we are using the online version of the Matlab. For reading data, we have created a code which is named mcode1.mlx. The .mlx is the live script file format in Matlab. Here we can add text in between the codes as comments, which can be used for describing the various steps in the code. In this particular code, we are using the Matlab function called read table for reading the data file. And in our case, the data file is carsales.csv. This is an Excel file, and here this .csv stands for comma separated values. We also need to save this data file in the same folder where we have included the code. Otherwise, we have to specify the path to the folder where the file is saved. Now, we can run this code by simply clicking run here. And this will display the table as here. We have read this table carsales.csv into a particular variable called D. Here this data corresponding to sales of different cars from manufacturers such as Acura, Audi, BMW, etc. And here this each column corresponding to different features such as model, sales in thousand, year sale value, vehicle type, etc. And we can see that we have such 16 number of features. And similarly, each row is corresponding to observations which corresponding to different cars. And if we go down, we have such 157 observations or 157 samples. So using this data, we can try to find some relationship between these parameters such as power, wheelbase, width, length, curb weight, fuel capacity, fuel efficiency, etc. to the price of the car. Or we can try to find some model which connect these parameters and the sales of the car. So in such a way that given these parameters, we can try to predict the price or sale, etc. So these things basically comes under a regression kind of problem. Another option is like given these parameters, we can try to find the type of the car, whether it's a passenger car or also the manufacturer of the car, whether this car is from this particular manufacturer. These kind of things will be basically comes under classification problems. For all these things, we can use various machine learning algorithms. Now here we have another data for a continuous factory process, which is corresponding to the observations from a particular process. And we can try to read this data in Matlab. Here this file is of format XLSX. So we have to specify the format correctly in order to read this file. Once we given the file name, we can just click run for reading this file. Here also we are reading this file into a variable named D, and in this case we can see that D has around 14,000 rows and 116 columns. So this is a very large data set. Here these columns corresponding to different features of this process such as ambient humidity, ambient temperature, etc. And we have such 116 features. And similarly, the rows corresponding to different observations. This means the observations of these features at a different time instance. And these time instances are listed here. We have a continuous time process, and what we take is different samples of this data, which are recorded here. Analyzing this large data is very difficult, so we have to find a model which can be used for finding the relationship between different features in the data. For example, how this ambient temperature affect the property of this raw material, or such things we can try to figure out. In compared to Matlab, Python is an open source programming language, so anyone can use it freely without any license. And in Python, we can implement machine learning algorithms using various libraries such as Keras, PyTorch, TensorFlow, etc. Next, we illustrate how to read data in Python. And for running Python codes, here we are using Google Colab, which is basically an online version of Jupyter Notebook. Here for reading data in Python, we have created a code named pcode1.ipynb. Here ipynb stands for Interactive Python Notebook, which is a file format used by Jupyter Notebook. Now in Python, we can use different libraries which contain special functions for implementing different algorithms. And for reading and operating data, we can use the Python library called pandas. And for using this in the code, we have to import it first. So here we import pandas as PD. Now in the rest of the code, whenever we have to use different functions from pandas, we can use it as pd.function name. For example, here we are using the function name read underscore CSV, which is a function used for reading CSV files. And this function is actually defined in the library pandas. So we call it like pd.read underscore CSV. And here we are reading this file into a variable called D, and this is actually the file name. Here we also need to load these data files into the Google Colab, and for that we can click here in files, go to this upload icon. Here we are selecting this flight dataset.csv and this another data which we are now loading to Jupyter Notebook. Once this upload is complete, we can see the data files here. Now we can run this code, and here we can run this code cell by cell. So here for running this first cell, we just need to click here. It will basically import this library pandas. And in the second cell, we are basically reading this CSV file into a variable D. And this head function is used for displaying a few rows of the data. Here by clicking on run, we can see the data and see how it looks like. One important thing to note is that in Python, the array index starts from 0. So basically the first row is indexed by 0 and it goes like that. However, in Matlab, the array indexing starts from 1. Now here if we change this value by 10 and run this code, we can see the first 10 rows of this data. Basically, if we didn't specify any number, it will display a first few rows in some default setting. And if we specify some number n here, it will display the first n rows. Now if we replace this number with length of d and run this again, we can see that there are around 3 lakh rows and 11 columns. And the columns corresponding to the features of this data, such as flight, source city, arrival time, duration, days left, price, etc. Here also we can use this data set for finding the relationship between duration and price. If you want to classify different airlines based on their price, we can use some algorithm. We can also use another function called print, which is also a way of displaying the data. This is a very large data set. And if you want to analyze this data for solving a particular problem, can use various machine learning algorithm. Finally, we can also consider one another data set, which is as given here. So here we have to specify the format correctly. So this is an XLSX file. So this CSV we have to replace with Excel. And now if we click run, we can see that this data has around 50,005 rows and 18 columns. This data set is basically corresponding to the data of different songs by various artists. So each column is corresponding to different features such as artist name, track name, popularity, duration, energy, etc. And finally, we have the genre as well, such as electronic, hip hop, which we can see here. Using this data for various songs, we can try to develop a model which predicts the genre for a new song. Here, this genre can be considered as a label, and this given features about this various songs can be used for training a model, using which we can try to predict the label for a new song given its features. Also, we can try to find a model which identifies which genre is more popular based on this popularity index. We can come up with different problems from this data and try to solve it using machine learning algorithms. The data sets used in these examples are open source data which can be freely downloaded from the website Kaggle. In the next few lectures, we will be discussing supervised learning and its different algorithms. The Matlab and Python codes for these lectures can be downloaded from the link given in the description. Also, one can go through the lecture notes, which is also given in the description. That completes this lecture. Thanks for listening.